pleased to introduce the first guest today, who will be talking about, well, should we actually make a blockchain ledger maybe immutable? Thanks so much.
First of all, I would like to thank you for coming to this session. My name is Elias Yosif, coming from the Blockchain Initiative from the University of Nicosia, Cyprus, and I will present the work of my colleague Konstantinos Karasavas, who implemented a system for revoking the records in an immutable ledger. So let's spend a couple of minutes to visit this, the title of this work. For some reason, the screen here is off. So yes. It looks like an oxymoron, for example, saying that we have a method for revoking records in an immutable ledger. How this is, possible and fits in the case of public blockchains? Because all we know that when something is published in the blockchain, it's there forever. So how this can be done, and when this option is useful? Can you have any ideas, guesses? A hint is the recent GDPR rules. So yes, let's make it a little bit interactive.
Yeah, I wanted to say the GDPR.
Yes. So actually, let's motivate further this idea, and let's take an excellent example from our own experience in the University of Nicosia, where we offer Masters in Digital Currency, and probably many of you have heard about the MOOC course. That is the very first course in this master, where we are offering at the completion of the MOOC and the master certificate of accomplishment, and of course an academic certificate. In many cases, there is the need to, and of course those certificates are published on the blockchain. We'll see an example towards the end of this talk. So we have certain requests from students for making minor modifications on their certificates. For example, someone is married at some time and wants to, add, change her surname by adding, the appropriate part in the string. So we have to do these changes, these updates. As my colleague mentioned, in the light of the recent GDPRs, the users have certain rights regarding their data, even the deletion of them. So this line of research is, I think, very, very important for various reasons that go well beyond the technological front. So I will need this screen in front of me, yes, now. So, several institutions issue physical or digital credentials. Obviously, this type of credentials go well beyond the academic certificates. Here you can imagine various types of certificates, ranging from driving licenses, land registries, etc., etc., etc. A common format for those certificates is, a usual hard copy or a PDF file. PDF is a widely used format that is portable, viewable in a wide array of devices, etc., etc. So, if in this paper we focused in the case of certificates, because mainly we are issuing academic certificates for our own graduates. So the area of certification in the arsenal of job seeking is quite huge. If someone go and read the statistics, she probably surprisingly find that a significant amount of falsified certificates are sent to the potential employers. And as a result, time is spent by the employer side for doing background checks and checking the certificates, etc., etc. So, a secure way for ensuring the validity of those electronic certificates is important. And at this point, I think that blockchain comes into the scene. So we propose in this paper a blockchain-based approach for securing this, for issuing PDF-based academic certificates, and then a central procedure for validating them by going to the Bitcoin blockchain and checking for certain characteristics. As an additional layer of functionality, we proposed a methodology that enables us to revoke when this is needed, as I explained in the beginning. When a graduate requests, for example, a change in his/her name, or a change, let's say, in the grade. Actually, what is done in summary is that we append some metadata to the certificates that are not viewable at the front end in the usual PDF viewer. So overall, this process, the issuing of academic certificates or certificates on the blockchain, should exhibit a series of characteristics. So the digital credential, assuming that we have it in the format of PDF, should be self-contained. A hash of the credential is stored into the blockchain and has, of course, the properties that we described, and of course the properties of the blockchain technology itself. Then a single issuance action can be used for issuing multiple certificates at the same time, because this comes at a cost. So instead of doing this certificate by certificate, we have developed a methodology for issuing at a massive scale. So a third point is that this should be permissionless in order to be open to anyone to use it. And of course, by saying use it, we mean the important part of the validation. The friendliness of this process is also another key factor. And the validation of the certificate should be ideally independent from the issuing institution, in order, to enable this step to be universal and doable by, any interested party. And of course, the main focus of this work was the revocation functionality that should be possible according to a decentralized way. Also, another desirable feature is that the identity of the issuing institute should be done in decentralized way, following the same spirit of the public blockchains themselves. So from an application perspective, the main parameters are summarized in these 5 bullets. This application should depend only on the selected blockchain. In our case, we choose the Bitcoin blockchain for various reasons. Also, anyone should be able to do a fast validation of the certificates without relying and conducting the issuing institution. Also, anyone can validate the certificates issued by this institution, even if the institution, for any reason, stops to exist. Imagine a company or a university or an organization that at some point in the future, for some reason, stops to operate. In this case, the validation of the certificates that were issued by this organization should be there and available to the public. And of course, we should ensure that there is no way to forge inauthentic certificates. And given the above characteristics at the usability level, this should be done easily, so let's say the potential project can easily view, share the certificates. So for our case, we work on Bitcoin blockchain that is, as you already know, decentralized, immutable, transparent, and of course open to everyone and extremely secure. Actually, for doing this, we take the fingerprint of a PDF file, we add some metadata, and we publish it on the main net of Bitcoin blockchain. Our actual implementation, as we will see at the end of the presentation, is open source, available to anyone to download it and test it. And as I was saying, we used it for issuing academic certificates, but this is not the only use case. By downloading our application, you can use it for issuing your certificates for your own use case. This diagram summarizes the overall process. So the idea is to have, I'm starting to describe the moving from left to right, top down. So in the first row, we saw the PDF itself that is being augmented by a CSV in our case. So what we do in this, and this is done automatically for multiple number of certificates. So in practice, we start with a PDF-based template, which is the actual design, having a certain number of form fields. The purpose of the CSV file or any other related plain source of info is to use the CSV in order to fill in the form fields, and this way we produce the multiple certificates whose number equals, of course, in our case, to the number of our graduates. Then those certificates, the metadata that came from the CSV are added as metadata within the source of the PDF, and those metadata are not viewable by the ordinary PDF programs, but you can retrieve them if you use the appropriate libraries. For example, I know that Python supports a number of them. Then see the certificates are combined in order to produce a Merkle root, which is incorporated within the op return command. And This is used in order to issue and send a transaction to the Bitcoin blockchain. And as a response, we get the transaction ID, which is also added within the set of the metadata. Given the completion of this step, the final phase is the distribution of the certificates to our graduates. So let's suppose that you are a graduate and you receive your blockchain-powered certificate. A possible use case is to, send your certificate as part of your CV to a number of candidate employers. Then the employer is also informed by you that this certificate can be verified through the Bitcoin blockchain. So the employer can upload this certificate to an appropriate server and validate it. And what is happening behind the scenes is that once we have a request for certificate validation, the added metadata are extracted, and then we follow, in essence, the reverse procedure in order to make sure that this certificate can reproduce the Merkle tree we had in the previous step. And if this is true, then a positive validation is returned as a response to the user. And in particular, our University of Nicosia, use this implementation which started as a prototype from 2014 for certifying the graduates of the DEFIN 511 Introduction to Digital Currency MOOC course. And I met quite a few graduates of this course in this event today, which was and is being taught by Antonopoulos, Andreas, and our CEO, Antonis Polemitis. And from spring 2017, all the university's diplomas are issued on Bitcoin's blockchain using this approach. And very recently, the revocation mechanism is available. Before see a couple of slides about our revocation approach, let's quickly review some existing approaches. The first one is to follow a revocation solution that is strongly centralized. And this is, let's say, a traditional approach that is by keeping a list of certificates that should be revoked. And in order to access and check this list, a URL endpoint is provided to the user. This is completely decentralized and has nothing to do with the blockchain, but we are referring to this for the sake of completeness. The other idea is, let's assume that we have 100 certificates and we need to do revocation for one of them. The brute force, let's say, approach is to reissue all of them. But this is, of course, easy to implement, but has a cost and requires very good management processes for doing this. The other approach, which it was followed before a few years by a team that do the same research on this area, is to associate some addresses with the user and the graduates. But this is not so practical. Imagine having thousands of graduates and trying to, convince them to have a Bitcoin address for receiving their certificates. This approach is similar to the very first one. The idea is to, maintain a list CRL list, which is credentials revoke list, and doing this in association with a blockchain and also providing a URL as an endpoint. The difference is that this list is now somehow related to the blockchain compared to the first one, but this introduces a single central point of failure. And the addition of an extra layer is a way to do this. And in the context of blockchains such as Ethereum, the exploitation of smart contracts can be used for this purpose, but at the end we will have more than one blockchain. And of course, one may use a revocation-specific blockchain, which is meant for handling the revocation. But the difficult part in this approach is how to convince user to run those nodes. In our work, we proposed a generic protocol, meta protocol, which is based on the op return command consisting of 80 bytes, which we think is quite simple, intuitive, and of course decentralized. The current protocol definition supports the revocation of up to 2 credentials at a time, and the idea is that the header of this protocol consists of 8 bytes. The first 4 are associated with the issuing institution, the other 2 about the version, and the other 2 bytes about the operation. The important part of this structure, of this header, is the operation. If you do the math, you will see, also this is mentioned in the paper, that a great number of operations are supported in principle. In this work, we proposed 5 operations where the idea is that we can revoke the TX ID as a first operation that is associated with a certificate. An extension of it is to add an expiry date. This can be expressed in terms of number of blocks or in terms of time, as the Unix system counts time beginning from the start of 1970. The third approach is I can have the respective TX IDs or the hashes of the file. And fifth method is to do the revocation with respect with the issuing addresses, which of course belong to the institution. Once this is done, the revocation part is implemented at the validation side, where we have a series of steps. In this slide, we give an overall summary. So when we receive a certificate, first of all, we validate the milk proof, ensuring that the issuing operation has at least one confirmation. Then we get all the transactions from that corresponds to the issuing address, and we check if we have a revoke address operation containing the address, and in this case, the verification fails. Otherwise, if we pass the test, the certificate is validated successfully. And we believe that our proposal constitutes a simple example approach for supporting this revocation, respecting the decentralization aspects of blockchain, and it is, of course, quite efficient. More and specific material is available through those links. most importantly, the first two links where you can download the actual code and play with it and see how it fits with your use case. And of course, try our validator that is available through the website of the University of Nicosia. And I think that we have time for a very short video illustrating the probably the main use case of this. So here we have two certificates. The user is from our Master in Digital Currency. Andreas Vlachos is my colleague. So this is the certificate. This is our validator, where the user selects the certificate that she received by your institution. Okay. With a single click, we need positive validation. With the metadata listed, those metadata were incorporated into the PDF. Here you can ensure that the transaction ID also appears within popular explorers containing all related issues. So another common practice for our graduates is just to, you are getting a certificate, you may rename it as my diploma. And of course, as you probably expect, that works. But we are illustrating this just to show you. Actually, when a user receives something, then we have an open, list of probable uses. One of them is the renaming of the file. So up to this point, everything is fine. But what about when a user tries to do something not so conventional? For example, she scans the hard copy. And here we have the scanned image of the certificate, or in a worst scenario, tries to modify the metadata. In this case, our blockchain-based validator says no. And this is an example how the main features of the blockchain are utilized to this specific use case to ensure the integrity of our certificates. Thank you for your attention. Please visit those links. A lot of material is available there, which is open source. Please.
Thank you for the presentation, very interesting. I see all this blockchain came from frustration from the third party. Now, you gave an example of backend, diplomas and so on. Is that possible that university in current format will disappear in 2 years, in 20 years? Because why do you need a dean? Why do you need a vice president? There are so many, and everything is transaction between the student and professor. Is that going to happen?
Don't have a really smart answer for this. Forecasting, predicting is, let's say, dangerous. But if I have to take a standpoint, I would say that both the traditional and the new world of blockchains eventually will be merged. And, probably we have both of them. However, this approach adds another functionality that in certain cases makes our life easier. However, a traditional old school certificate in a frame, hard copy, will be, I suppose, appreciated by all. So let's combine the good aspects of both worlds. So this is my prediction.
You are a diplomatic educator.
Any more questions? We have time for one more short question over there. Over.
What's your position or short-lived credentials?
Of?
Short-lived credentials. Because for some kind of credentials, the community decided that education systems are complex and difficult to implement, so they reach consensus that it's better to have like short-lived credentials.
Can you give an example in order?
Yeah, sure, like public infrastructures over ticket infrastructures or this kind of.
Yes, I see. Currently, we are focused only on the academic certificates, where this is, let's say, a special case, because, you know, I suppose that no one will have a problem about his certification because it's a type of accomplishment. So in this case, things are easier. And what you are asking is a considerable challenge. We have not worked in other fields other than that, but I suppose that my colleagues that are going to download our system will have to make the necessary adaptations for handling such cases. So yes, probably the academic certificates is it's a good use case, but, you know, all the users are probably happy because, you know, they are accomplishments.
Thank you so much.